Okay, children. So already we have seen that topic, electricity. In the electricity, do you remember what we have learned? Electric current, circuit elements, potential difference, and the formulas. What is electric current formula? I is equals to Q by T. Potential, V is equals to W by Q. So we have done the proper revision also of those questions. Today we are going to see another topic, Ohm's law, and after that we are going to discuss factors affecting the resistance. So these two topics we are going to discuss, Ohm's law and factors affecting the resistance. So before going into the topic, what is the Ohm's law? See Nana, you have seen the battery and household power supply. Will we get the electric shock for the battery current? You tried some experiments and you made lit some bulb, no? Did it give shock? No, you happily, without any fear you did. But when we work with electric current, we need to take lot of precautions. It gives electric shock. Why? Because more current flows in the wire. Question comes, why more current flows in that wire and why less current for the battery? That answer we are going to see now. So Ohm's law, to understand the Ohm's law, let me go through the activity. Now see the experimental setup. In this experimental setup you can see that a resistance is connected, battery, but you see that how many batteries are there? 4 batteries are there and 4 different connections are there, and voltmeter and plug key. So this setup is such a way that we can connect one cell one time, and if I connect the wire with the next one, 2 cells, means 2 cells will become one battery, next 3 cells, 4 cells. So what is we are doing in this activity? We are increasing the cells. Now as after the connection, you keep the one cell, note down the reading in the ammeter and voltmeter. You remember, ammeter we need to connect in series. See that ammeter is connected in series, voltmeter is connected in parallel across the resistance. Now these two values please note down. When one cell is connected, 2 cells are connected, 3 cells are connected, 4 cells are connected. What did you observe? Yes. When we complete the experiment, we will find that as the number of cells are increasing, potential difference is also increasing along with the current. So you can easily identify that when we increase the potential difference, current in the resistance also increasing. So potential difference across the terminals of the resistance is directly proportional to the current passed through it. This is what Ohm's law states that. When we remove the proportionality constant, then the formula will be V is equals to IR. Remember the third formula we got here, V is equals to IR. Now let me see the another activity. It's that when more potential difference is there, more current flows through the circuit element. V is directly proportional to I. Now let us see another activity 12.2. So look at here I left that in this activity there is a gap between A and B. In this A and B I am going to connect 3 different wires. One nichrome wire, one 10 watt bulb, one small bulb, torch bulb. And every time I am going to see the ammeter reading. So now first I have connected the nichrome wire. I noted down the ammeter reading. Second, I connected the 10 watts bulb. I noted down the current reading. Third, I connected torch bulb. I noted the current reading. So now observe the reading. What information you will get from that observation. You will say that, sir, values changed. Yes. Why different currents have to be moved in that resistances, means in that objects? When torch bulb is there, you will find that more current. When nichrome wire is there, less current. What happened? Yes, it is the different materials provides the different opposition. We know that every conductor is made up of different atoms, and this atomic arrangement is the responsible. What is electric current? We all know that flow of electrons are responsible for the electric current. These flow of electrons has to go through the atomic arrangement. So different arrangement produces different opposition. That's why these flow of electrons will not flow in the same manner in all the materials. That opposition restricts the flow of electrons. This opposition for the flow of electrons, we call it as resistance. Resistance depends on what? Resistance depends on what? First of all, just now we have seen an experiment. It's different materials means different resistance. But let me see another activity. Now we are going to identify what factors are responsible for the resistance. See, Nana? Look at the activity 12.3. So in this activity, I have arranged as per the circuit diagram. You can see here one wire is of one length, another wire is of double length. You can see V mark, double length. Now there another wire with thickness, but same length, thickness is different. Now I have taken three wires. If you take first two, second one is the double length, first and three, third one is double thickness. Now do the experiment. First take the resistance current when the single wire is there. Now repeat the same experiment when the wire length is doubled. You will see that current value is reduced to half. As length doubled, current in the circuit reduced to half. What happened? As length increased, current decreased. Current decreased means opposition increased. Opposition increased means resistance increased. So as length increased, resistance increased. So one factor we came to know that resistance depends upon length and it is directly proportional to. So resistance of the conductor is directly proportional to the length of the conductor. Now repeat the same experiment. First same length, second also same length, but what is the difference? Thickness is double. You will find that current value is increased. How? Because the thick wire provided less resistance. The thick wire provided less resistance means as thickness is increasing, resistance value is decreasing. As thickness is increasing, resistance value is decreasing. It means here resistance is inversely proportional to the thickness of the conductor. The resistance value increases if thickness is decreases. If thickness increases, resistance value decreases. So that's why as resistance value is decreased, more current is flowed in the circuit. So second we learned the resistance of a conductor depends upon its thickness, area of cross section. So R is inversely proportional to A. When we write, we have to write it as 1 by A. So two factors we learned now. One is length, another one is thickness. Now repeat the same experiment with different wires. Will you get the same value? No. Means resistance of the conductor depends upon material also. That is what we are going to see now. In the first first experiment what we got, R is directly proportional to L. Second one, R is inversely proportional to A. Now when you combine these two, what we got? R is proportional to L by A. Now when we remove the proportionality constant, we got the proportionality constant rho. This rho is called specific resistance of the material, or simply resistivity of the material. This value will tell us that whether that particular wire is conductor or not. Now observe the table given in the question. Now which are having the high resistance value, specific resistance value, are the insulators. They don't allow the current. Which are very good conductors, which are having the low specific resistance value. You can observe the table and you will find that silver and copper are the best conductors because they have the very less specific resistance. So now, what we have come to know that resistance depends on what? Three factors: length, thickness, and as also material, nature of the material, and also it depends on temperature. But because entire experiment setup we made at constant temperature. If room temperature that changes, if temperature of the wire changes, then also resistance will be changed. As temperature increases, resistance also will increase in conductors. Okay, now 4 points we learned. What are the factors that are responsible for the resistance? Length of the conductor, thickness of the conductor, nature of the material, temperature. This is what we learned in this particular topic. Okay, now we are going to see problems. Take out your textbook and look at the example 12.5. Read the question. Now, whenever we do a problem, I always explains to you, find out the data given in the question. What is the data given in the question? Here, 1 meter length wire having 26 ohms resistance. And thickness of the wire, diameter is given 0.3 millimeters. They are asking us to find specific resistance. See Nana, data, when you write L is equals to 1 meter, R is equals to 26 ohms, thickness D is equals to 0.3 millimeters. Milli means 10 power minus 3. Now can you find the area? Yes, area is equals to pi d square by 4. When you substitute, you will get the area value. Now they are asking to find out the rho, specific resistance. Now second thing, when we write the data, what is the second thing? What formula we need to write? What formula? Yes, it is R is equals to rho L by A. From this find the rho value. Rho is equals to R A by L. We have the resistance value. In the place of A, write pi d square by 4, L value also there. Substitute the values. And what is the answer we will get? 1.84 into 10 power minus 6 meters. Difficult in calculations, but you try. You will get the value as 1.84 into 10 power minus 6 ohm meter is the answer. So whenever we do a problem, first we need to write the data. Second, find the suitable formula. This suitable formula we need to get from the available data. So as I got the formula, I substituted the values and I get the answer. Now look at the example 12.6. Here different data is given. For a particular length and thickness, the resistance of the wire is 4 ohms. Now the length is length is half and thickness is doubled. They are asking the new resistance value. Now without disturbing the values and all those things, what is the resistance formula? R is equals to rho L by A. Now new resistance I took R dash rho. As material is not changed, no need to change the rho. Length is changed. What is that? L by 2. Area is changed 2A. Now what we will get? Rho L by 4A or else R by 4. Means new resistance value 1/4 of the old resistance. What is the old resistance value given in the question? 4 ohms. So 4 by 4, how much? 1 ohm. Okay Nana? This is way we need to do the remaining problems also. Now observe the textbook questions. What is the first question? What are the factors that are affecting the resistance? 4 factors: length of the conductor, thickness, nature of the material, and last one, temperature. Now you can see that thin wire, thick wire. Which one? Here they said that the thin wire is providing more resistance and thick wire is providing the less resistance. As less resistance is there, more current flows in the thick one. Now the third one, here they changed, they did not change the resistance value in that question. They said that potential difference is made it to off. As it is directly present, the current also will be reduced to off. I hope so that you understood these 3 in-text questions. The remaining 2 questions you try, and worksheet also will be provided to you. Please answer the questions. Thank you.